Assalamualaikum and hi everyone. In this video, we're going to explain about basic connectives and truth tables. We're going to go through 5 parts in this topic. The first part is statement and proposition. The second part is negation. The third part is conjunction and disjunction. And fourth, implication and biconditional. And the last one is truth table. Why is this topic important? This topic is important because they are the foundation of mathematics, programming, and computer science. It helps us understand how logical statements work. Truth tables, which clearly help us to see whether the statement is true or false, which then will help us to avoid logical mistakes and make correct decisions. Hi everyone, my name is Nur Khairun Sahani and I'm going to explain about statements, which also known as proposition in discrete mathematics. So what is a statement? A statement is a sentence that is either true or false, but not both. So as long as we can decide whether the sentence is true or false, then it is a statement. However, not all sentences are statements. Questions, comments, and exclamations are not statements because they do not have a true or false value. In logic, we usually represent statements using lowercase letters such as P, Q, and R to make them easier to work with. There are two main types of statements. The first one is primitive statements. A primitive statement is a single idea that cannot be broken down into a simpler sentence. For example, the tree is green. Show the tree, please. The second type is a compound statement. A compound statement combines two or more simple statements using logical connectives such as not, and, or, and, if, then, and if and only if. For examples, if she passed the written test, then she passed the road test. This is a compound statement because it connects two simpler statements using if, then.
Assalamualaikum and to everyone. My name is Nur Syashakrata Ain binti Muhammad Zaidi, and today I would like to present what is negation. Negation. What is negation? Negation means saying the opposite of a statement. For example, if something is true, the negation is false. If something is false, then the negation is true. For example, in a statement, the sky is blue. This is the original statement. But for the negation, the sky is not blue. Next, the original statement, cats can fly. But for the negation, cats cannot fly. Then, how to spot a negation? For example, we should look for the words keyword that write not, does not, cannot, never, and whatever it is. And for the negation symbol is like this. If we want to use the negation in real life, for example, I like pizza. But for the negation is I do not like pizza. That's all from me. Thank you.
Hi and Assalamualaikum. My name is Nur Khairun and today I am going to explain about what is conjunction. Okay, conjunction is when both statement must be true for the whole statement to be true. A conjunction written as P, Q and read as P and Q.
For example, the light bulb turns on only if switch A is on and switch B is on. This means if both switches are on, the light will turn on. But if one of the switches is off, the light will not turn on. Now, let's look at the cases for conjunctions. In case 1, switch P is on and switch Q is on. So P is true and Q is true. Because both are true, the result of P and Q is true and the light is on. In the next case, switch P is on but switch Q is off. Here one statement is true and one statement is false. So the result of P and Q is false and the light will turn off. And for the case 3, if both switch P and switch Q is off, the result is still false. This shows that for conjunctions, both conditions must be true.
Okay, then I will explain about what is disjunction. Disjunction is at least one statement must be true for the whole statement to be true. A disjunction written as P, BQ and read as P or Q.
For example, the bird will jump if button P is pressed or button Q is pressed. This means the bird will jump as long as at least one button is pressed. Let's look at the cases for disjunction. In the first case, both button P and button Q are clicked. So P is true and Q is true. The result of P or Q is true. In the next case, only button P is clicked and button Q is not clicked. Since one statement is true, the result is still true. However, if both button P and button Q are not clicked, then P and Q are put false. So the result of P or Q is false.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Noiman, and next we're going to look at implication. Implication is translated to if then. So if P then Q. This is the symbol if P then Q. P is the hypothesis while the Q is the conclusion, or you can say it is a promise. For a statement to be true, the Q or the conclusion has to be true. Okay, let's look at the example. The first example is you clean the room, I give you candy. The promise is kept, so the statement is true. The second example is you clean the room, I didn't give you candy. Even though the promise was made, but they didn't keep their promise, so the promise is broken and the statement is false. The third example is you didn't clean your room, I give you candy. So the promise is kept, so the statement is true. And the last example is you didn't clean, no candy. So there was no promise in the first case, so the promise was not broken and the statement is true. Next. Alright, next we're going to look at biconditional. Biconditional translated to if and only if or IFM. So this is the symbol P if and only if Q. P if and only if Q. So P and Q are equivalent statement. When P is true, Q is true. And when P is false, Q is false. Okay, let's look at the example. If I sleep late, if and only if it's Saturday, true, true, so the statement is true. The second example, if I sleep early, if and only if it's Saturday. I sleep early is false. So the statement is false. The third example, if I sleep late, if and only if it's Thursday is false. So true, false, the statement is false. And the last statement is I sleep early if and only if it's Thursday. So false, false, the statement is true. That's all for me. Next.
Hello everyone, my name is Aisha Shaira, and today I will explain about logical connectives and truth tables using a simple real-life example about studying for a test. First, we define our primitive statements. We let P be I study for the test, Q be I pass for the test, and lastly R I review my notes. Each of these statements can only be either true or false, which makes them suitable for logical analysis. Our first logical sentence is P implies Q, written as it on the board here. In words, this means if I study for the test, then I pass the test. This is a conditional statement. It is false only when P is true and Q is false. From the truth table, we can see that when I study but I do not pass the test, the statements become false. In all other cases, the statement is true. The next sentence is not R and Q. This means I will not review my notes and pass the test. Here, not R represents I do not review my notes, and this symbol here means and. The conjunction is only true when both parts are true. From the truth table, we can see that the statement is true only when I do not review my notes and I still pass the test. Next is this sentence is P or R implies Q. In words, if I study or review my notes, then I pass the test. The symbol V means or, which is true when at least one statement is true. This conditional statement is false only when P or R is true, but Q is false. The truth table helps us clearly see when this situation happens. Our final sentence is not P and R implies not Q. This means if I do not both study and review my notes, then I do not pass the test. First, we evaluate the P and R, which means studying and reviewing my notes. Then we negate it to get not P and R. We also negate Q to get not Q, meaning I do not pass the test. According to the truth table, this conditional statement is false only when not P and R is true and not Q is false. Okay, that's all from me. Thank you. So, to wrap things up, today we talk about statements, truth value, and logical connectives. We started by understanding what a statement is and how it can be either true or false. Then we look at different logical connectives like not, and, or, implication, biconditional, conjunction, and disjunction, and how they connect statements together. Finally, we use truth table to clearly see when these statements are true or false. Overall, these concepts help us think more logically, avoid mistakes, and understand how reasoning works, not in just mathematics, but in real life situation as well. Thank you for watching, and we hope this video made logic easier to understand. Bye bye.
The foundation of mathematics, programming, and computer science.
How?
So the little girl.
Test.
Means is just a simple sentence. Come on. Is this one?
Next, we're going to look at the